Hey guys, welcome back. In this particular video, we're going to be taking a look at one of my favorite topics and a very important topic called IP subnetting. In this particular subject, what we do is we take a look at the networks and make more efficient use of the address space that we have at our disposal. In this particular video, we're going to take a look at what subnetting is all about. We'll take a look at some basic subnetting examples. We'll take a look at simple subnetting steps that allow you the ability to do subnetting without looking at any calculators or paper or pencil. You should be able to do subnetting off the top of your head. That's what I want you guys to get to in this particular video. So if you pay attention to this video, give me your undivided attention, you will be able to do subnetting uh, without using any paper, without using any calculator off the top of your head. All right? So a very exciting module over here coming up. But before we get started, let's understand, why do I need subnetting? What is the purpose of subnetting? We have taken a look at, in the class addressing space that we looked at, that the smallest network that I have is a class C network. Smallest in the sense of what? The size, the number of hosts on a particular network. So if you take a look at the smallest network that we have over here, the smallest network that you're going to have is a class C network. Even that network, if you take a look at it, has 254 hosts on it. We already did that calculation in the IP addressing video, a couple of videos ahead, I think. Let's say I have a network in which I want to get a bunch of different networks. I have a company which has a bunch of different networks, and I want to get a range of public addresses from my ISP. In my company, I have a requirement of having 4 separate subnets, or 4 different networks that are isolated, that are connected to each other using that device that connects different networks to each other, the router. They're different departments, and each department wants to be on its own network. But the thing is, in my company, these 4 networks that I have, they only have about 25 hosts each. So let's say the sales department, the marketing department, the accounting department, all those departments, executives, different network for that, each one of them has 25 hosts on it, connected via a router. Now I want to get public addresses from my ISP. I go to my ISP and say, hey, listen, I need to get 4 networks. He goes, okay, if you need 4 networks, that means you have about 1,000 hosts. You go, no, I don't have 1,000 hosts. I only have 20. I have 100 hosts. Says, okay, why do you need 4 networks? Why don't you take one network and break it down into smaller networks known as subnets, subnetworks? And you say, what is a subnetwork? Well, a subnetwork, he tells you, is basically a network which is divided into smaller networks. And that's what I'm going to show you over here, is how to accomplish that. Taking one network, which is already there with 254 hosts on it, breaking it down into a smaller set of networks. The way I do that is because my requirement of the number of hosts is less. Rather than getting one network with 254 hosts on it, what I will do is I will break that one network in. Let's say we'll take an example of a network that the ISP assigns me, 200.1.1.0. Based on our previous videos, you know that on this particular network, I have 254 hosts. I have the last 8 bits dedicated from my host. The first 3 octets are my network portion. And the other way I write the subnet mask is 255, 255, 2550. This is what we have already established. Now, what I can do over here is I can break this last octet down in such a way that by default, although these are all host bits, I'm going to take away the host bits and assign them as network bits. So for example, I need 4 networks, what I can do is I can take 2 bits away, these 2 bits away, and put them as network bits. By doing this, I gain 2 bits worth of networks. How many is 2 bits worth of networks? If I borrow and take away 2 bits away from the host portion and give it to the network, I get 2 to the power of 2 times new networks. So 2 to the power of 2 is 2 times 2, which gives me 4 new networks. What are the 4 new networks? If you take a look at these 2 bits, the different combinations that you can get from them is 0, 0, 0, 1, 1, 0, 1, 1. So I'll get 4 new networks by borrowing 2 bits. And remember, I had 4 networks or 4 different departments. I can take these 4 networks and assign those to the 4 different departments. But now on each one of the networks, I will not have 254 hosts because I don't have 8 bits left for my host bits. I only have 6 bits left for my host bits now. 1, 2, 3, 4, 5, and 6. Now, how many hosts is that per network? Just like 2 to the power of 2 is 4, we'll do 2 to the power of 6, which is 64 new hosts. So on each one of those networks, I won't have 254 hosts. I will have 64 hosts each. But if you guys remember, we also talked about on every network, on the host portion, all zeros represents the network address and all ones represents the broadcast. So these 2 addresses cannot be used. So I will lose 2 addresses and I'll get a total of 62 usable addresses over here. So rather than having one network with 254 hosts, I'll get 4 new networks with 64 usable hosts by taking these 2 host bits and giving them to the network. And if you take a look at it, it is a little bit more efficient in the way I'm doing things. Rather than assigning 4 networks and losing out on a whole bunch of different IP addresses, I take one network and split it into 4 and getting enough addresses over there. Does that make sense, guys? And that's what subnetting is all about. This is basically subnetting, where you take away the host bits, borrow them and put them as new networks, and that becomes your subnet. So in this component, these numbers, if I want to write it, the network address, if you remember the magic table that we talked about, remember the 128, 64, 32, 16, 8, 4, 2, 1. Because I borrowed 2 bits on the network side, my 4 new networks are going to be created over here. And of what are my 4 new networks? 0, 0. So 0, 0 is going to be 200, 1, 1, 0, because 0, 0, and this is my network bit, this address. But the mask now is not going to be, it's not going to be 24, it's going to be 26 because I borrowed 2 more bits for my network bits. Not only that, if you remember from the subnet mask, if I want to write the long mask, it was 255, 255, 255, and the ones represented the network bits. So on the last octet, I turned the first 2 bits of the last octet into my network bits, which is the 128 and 64. That would give me a new mask of, if I want to write it in this format, 255, 255, 255.192, that becomes my new mask. That's my first network. My second network would be 0, 1. What is 0, 1? 0, 1. Actually, let me just write it down over here for you guys. All of them one at a time. All 4 of them. It would be 200.1.1.0/26, or with a mask of 255, 255, 255, 192 because I borrowed the first two bits as network bits, which is equivalent to this. My second network is 200.1.1.01, which is 01 is 64. That becomes my new network address. Again, /22, same mask because it's the same number of bits that I have. The third network will be 10, which is 200.1.1.10 is 128 /26, again the same mask. And the last one is 11, which is 200.1.1.192 /26. That's my fourth network. So I gain 4 networks by borrowing 2 bits, but I do lose on the overall number of hosts. I had one network with 254 hosts. Now I have 4 networks with 62 hosts, 62 usable hosts total, which actually in reality does not give me the same number of addresses. I will basically have 248 hosts. If you multiply 4 by 62, you get 248. So you lose about 6 hosts over here. But you gain more usable networks because I needed 4 networks for 4 different departments. This is a better way of doing it. And this is known as subnetting. In this particular subnet, you have 2 networks. This over here is your major network. 200.1.1.0. This was the major network that was given to me by my ISP, and I split it into these smaller networks with bigger masks. So this is where the borrowing took place. I borrowed from my host portion, gave it to my network portion, giving me subnets. These are known as subnets. So in this particular network, I have my major network, which is the full class network, class A, class B, or class C, and whatever I borrowed becomes my subnet, which is a subnetwork of that major network. So this is basically what subnetting is all about. Now, I want to make it easy for you guys so that you can do it, as I said, off the top of your head rather than looking at some calculations of, binary or calculators and all that. You should be able to do it in your head. So as a recap of subnetting, normal class A, B, or C networks have a lot of hosts on a single network. We'll take a look at A and B later on, but let's focus on C over here. Even C has 254 hosts. This leads to a wastage of addresses on a single network. I gave you an example of that. And to get around that, I will use subnetting. What does that do? It allows me to take away from your host portion. If I don't have a requirement of that big of a number for my host portion, take it away and give it to what? My network portion. The number of bits I take away and give depends on the requirement. The requirement will basically be the number of sub networks that I need. So if I need 4 networks, 2 bits is good enough. If I need more, I need to borrow more bits. I can borrow more bits, but as soon as I borrow more bits, I will lose out from my host portion. So let's say I borrow 3 bits. If I borrow 3 bits, the number of new networks that I get is 2 to the power of the number of bits that I borrow, which is 3, which is 2 times 2 times 2, which is 8. But now on each one of those networks, now I only have what? 5 bits for the host, which is 2 to the power of 5, which is 32. Again, we already established that you lose 2 addresses per network, the network and the broadcast. So I only have 30 networks. So I'll have 30 hosts. I'll have 8 networks with 30 hosts if I borrow 3 bits. So on and so forth. We'll get into detail about that as we go through it. Subnetting allows you to create multiple logical networks. These networks created by using host bits for networks are called subnetworks. The main network is called the major network. So the terminology, the main network that you broke down is the major network. The new networks that are created are called subnetworks, but popularly known as subnets. So let's take an example over here. Let's say a company required 20 public IP addresses on a network. Or let's take it the other way around. This is okay. Let's take this example. On each network, I needed 20 public addresses. If the ISP assigns them a Class C address, the Class C address gives a minimum of 254 hosts, but I only need 20. So if the ISP assigns a Class C address to this company, I would have lost 234 hosts or addresses because I don't have that number of hosts on this network. And that's what subnetting will allow me the ability to do: break the Class C network into smaller subnets and give smaller subnets based on the requirement. And that's what this whole video is dedicated for. Very important concept in the world of networking. So to do this, let's start by looking at a very basic subnetting example. Let's say my requirement in my company is to break my network down to 8 new networks with lesser number of hosts on it. So if I need 8 new networks, let's go back onto my whiteboard over here. So my main address that I had was 200.110/24, and my requirement is for 8 subnets. Now, the first thing to find out or figure out is the number of bits that I need to borrow. If I borrow 1 bit, it is 2 to the power of 1. That basically means I get 2 networks. If I borrow 2 bits, it gives me 4 combinations, 2 to the power of 2. If I borrow 3 bits, 2 to the power of 3 gives me 8 combinations, so on and so forth. All right, I have a table that I will help you in creating, or rather than doing this math to figure that out, I have a table that I want you guys to create. Start the table with 1, go all the way to 7. So 1, 2, 3, 4, 5, 6, and 7. All right, this is going to be my number of bits to borrow. Now to figure out the number of bits to borrow, you start on the bottom line over here, and what you do is you start under 1, again going from right to left. You start with the number 2 and keep on doubling all the way across. So what's a double of 2? 4. What's a double of 4? 8. Double of 8, 16. Double of 16, 32. Double of 32 is 64. Double of 64 is 128. Now, to figure out the number of bits to borrow, you can either do this, and once you do it enough, you know how many bits to borrow because these numbers become second nature. But for right now, because you're learning, if I want to get an X number of networks, I go on the bottom line over here and move from right to left until I hit the number that I need. So if I needed 10 networks over here, 1 bit would only give me 2. 2 bits will only give me 4. 3 bits will give me 8. I need 10. So I need to go to the next level, which is 16. So I'll borrow this number of bits. 4 bits, I'll get 16 networks, which satisfies my requirement. 8 would not satisfy it, so I would need to borrow 4 bits. So this table over here, again, I have it in your slides as well, helps you in figuring out the number of bits to borrow. This is an important table that I'll use for subnetting, my subnet table. All right, how did I create this table? Just to recap, on the top line, you go 1, 2, 3, 4, 5, 6, 7. On the bottom line, you start with 2 and double up. 2, 4, 8, 16, 32, 64, and 128. Now to figure it out, again, right to left, if you need an X number of networks, let's say we do another example over here. I needed, let's say, 25 networks. If I needed 25 networks, 25, if I borrow 4 bits is not good enough. I need to borrow 5 bits. I'll get 32 networks, which is more than what I need, but it's okay because 4 would not give me enough networks. So I need to borrow how many bits? The corresponding number of bits need to be borrowed. So 5 bits to get me my 25 networks. So that's how you figure out how many bits to borrow, by looking at this table. 1, 2, 3, 4, 5, 6, 7 on the bottom one, 2, 4, 8, 16, 32, 64, 128. This is the number of bits to borrow. This is the number of networks. All right, this table is known as my subnet table. I'll show you that later on in my examples as well. So now I've figured out the number of bits to borrow. So going back to that example that we started off, let's just do that example. It says I need 8 new networks over here. Do you guys see that? My requirement is 8. Oops. I needed 8 new networks over here. Okay. 1 second. Get rid of this. All right, better. There you go. So I need 8 new networks. So how do I get that? Again, going back to my table. I'll write that table one more time for you guys so that you can figure that out. 1, 2, 3, 4, 5, 6, and 7. Start with 2, keep on doubling. 8, 16, 32, 64, 128. And if I need 8 networks to be created, I need to borrow 3 bits. So that's the first thing I need to figure out, is how many bits do I need to borrow to fulfill my requirement. Now once I figure that out, my third thing that I need to do over here is write the new subnet mask, because now the number of bits that I need has changed. Not need, sorry, the number of bits that represent my network portion has changed. Before, my network was 200, 110/24, or you could have said 200.1.1.0, 255, 255, 255.0. Now that has changed. Now what is the new number of bits that I need to borrow? I need to borrow another 3 bits. So that number automatically becomes 200.1.1.0/27 because I'm borrowing 3 extra bits. Now to get this part of it, again, I'm borrowing the first 3 bits of the last octet. In my magic table from the previous videos, if I'm borrowing bits or using network bits, the network bits in my subnet mask are 1s. So 255, 255, 255. The first 3 octets completely are network bits. In the 4th octet, now the first 3 bits, which is this bit, and this bit, are going to be network bits. The rest of the bits are going to be my host bits. So how do I represent that in this format? Adding 128 plus 64 plus 32. That number over here becomes 224. All right. So you could write it like this, or actually, I'll leave it as is. This one would have been 200, 110, 255, 255, 255, 224, because 1 represents the network bits. Now I have 3 new network bits in the last octet. The last 5 bits are going to be my host bits. So this part is my next thing, which is to write the new subnets. All right. Now that I've written my subnets, I now need to figure out what are my 8 new networks. It said I got 8 new networks. What are the new network addresses? Well, what are the new network addresses? The way you write it, I'm going to do it in binary so that you guys understand it. If I borrowed 3 bits for my network portion, that is the first 3 bits over here. What are the 8 new combinations that I get for my network portion over here? 0, 0, 0 is my first new network. 0, 0, 1 would be my second network. 0, 1, 0 would be my third network. 0, 1, 1, fourth network. 1, 0, 0, fifth. 1, 0, 1, sixth. 1, 1, 0, 7. And the last one is 1, 1, 1. These are the 8 new networks that I gain by borrowing 3 bits, which is the 8 different combinations that I get with 3 bits. So these are my new subnetworks. The way I would write it, again, do you remember on every network I don't use the host portion of all zeros because that represents the network? That is this guy over here. So my host portion will be the last 5 bits turned to all 0. That would be my first subnet with a mask of /27 because it's the first 3 octets plus the first 3 bits of the last octet. 27 bits is my mask. If I want to write it in decimal, it would be 200.1.1.0/27. Why 0? Because the value over here becomes 0. 0, 0, 0, 0, 0, 0, 0 with a mask of 27. The second network is 0, 0, 1 because the network portion will, on the network address, the host portion remains all zeros. This is 0, 0, 1, 0, 0, 0, 0. If you remember, if I want to convert this binary into decimal, this number becomes 32. So my new network, the second subnet is going to be 32 because I have 001 as my subnetwork address. A third one, 000, 00 for my host portion. This is my host portion, the 5 bits. This is 010. 010 is 64. So the new network in decimal, I would write it as 64/27. This is 011. 11 is 96. So 200, 1.1.96, 27, so on and so forth. These are my new networks, the 8 new networks. So again, to recap the 4 steps so far. Number 1, figure out the number of networks required. This is based on your actual requirement. Number 2, figure out or find the number of bits to borrow. And how do I do it? Remember the table? 2, 4, 8, 16, 32, 64, 128. Let's say I had a requirement of 10 networks. I would go 1, this is not enough, this is not enough, this is not enough, this is enough. So this is the number of bits to borrow. So that would have been 4. My third step, write the new subnet mask. Now the 2 different ways, I'll show you both. I borrowed 4 bits in this particular example. So it had started as /24 plus 4 becomes /28. Why plus 4? Because I borrowed 4 bits. Or if I borrowed 4 bits, again, the first 4 bits will be my network portion. The last 4 bits in the last octet would be the host portion. So if this is the number, this is my subnet mask, 128, 64, 32 plus 16. If you add them up, it becomes 240. So 255, 255, 255, 240. All right, that was the third step. The fourth step, write the new networks. And how did I figure that out? Again using binary, 200.1. And the last one, the different combinations, we said 000, which would be 200.1.1.0/27 because I borrowed the 3 bits. The next one, 001, which is, again, if you remember this, 200.1.1.32, 010, 64/27, and so on and so forth. So that's how you do subnetting so far. One last thing needs to be done, but I'll do it as part of the example now. So again, let's do this example over here. I just did it for you guys, but let's recap it. So we wanted to break it into 8 new networks. We'll do this by taking the host portion, the last 8 bits, and splitting it up into some bits for networks and some bits for hosts. Let's take away the first 3 bits. We already looked at 2 different ways of figuring out if I take 3 bits, I'll get 8 new networks. Why 8 new networks? 2 to the power of 3 is 8, but I also showed you the other way of doing it, that table, the subnet table that I showed you. Much easier to figure it out on that table. And I'm going to use that table for something else later on as well. So that's an important table that I want you guys to be aware of. So when I do that, now my first 3 bits on the last octet become my network bits. The last 5 remain as my host bits. That means if I have 5 bits for my host, 2 to the power of 5 is 32, minus 2, 1 for network, 1 for broadcast, cannot be used. So I get 30 hosts on each one of those 8 networks. The new mask, 255, 255, 255, and I write it in binary now. 111, 0, 0, 0, 0, 0 represents the host, 1 represents the network. So 111, again, 111 is 128 plus 64 plus 32, which is 224. Or you can say I borrowed 3 bits. I started with 24. Now I become plus 3 is 27. So that's what the 27 is. That's what the 224 is. All right. And I also talk about by getting 3 bits, you get 8 new combinations. 2 to the power of 3 is 8. And in the host portion, I'm left with 5 bits for the host. That means 32 combinations. 2 to the power of 35 is 32. But out of the two addresses cannot be used. All zeros in the host represent the network. All ones in the host represent the broadcast address. So those 2 cannot be used. All right. So based on this, I have a table that I've created for you guys right after this to show you the breakdown. Again, doing the same things. To summarize the previous slide, to summarize, by borrowing 3 bits from the host portion, we get the following 8 networks all with a new mask of 224. 255, 255, 255, 224, or /27. Now, what are those networks over here? The first one is 000. We talked about that. The second one is 001, 010, 011, 100, 101, 110, 111. All right. And if I write that in decimal, this is in binary. In decimal, it is 200, 110, 200, 1132, 200, 64, 96, so on and so forth. Now, the last step that you also need to figure out to make it easy for the network administrator to assign the hosts. What are my host bits? Now, let's analyze the last octet over here because it's split. The first 3 octets, I know it's 200, 111. That's my major network. In the last octet, on my first network, I have my first 3 bits as my network bits, which are set to 000. My first host on that network will be 00001 because 0 cannot be used. That becomes my first usable host. And now when I write it, when I assign it to my device, I'll say 200, 111, 0000001. That in decimal becomes 200.1.1.1/27. So the first 3 bits over here are network bits. The last 5 are host. So that is my first usable host on that 200.110 network. So I need to write my first usable host. The other thing that I also want to write is the broadcast address on that network. My broadcast address on this particular network, the network being 000, would be all my host bits turned to 1. So all my host bits turned to 1 is my broadcast address. That is 000. This is 16 plus 8, which is 24, plus 4, 28, plus 2, 30, plus 1, 31. So my broadcast address on this 200.110 network, this network over here, is 31. So 200.1.1.31/27. And the last usable address on this particular network, 000, is going to be 11110. Why 10? That's the address before the broadcast. And if you add that up, 16 plus 8, 24 plus 4, 28 plus 2, 30 and 0. So that's the last usable one. You can give this information to your administrator saying, hey, listen, your usable address space on that 200.110/27 network is 200.111 and 200.111.30. So that's what I've done in this particular table over here. If you take a look at it, this is my first usable address, my last usable address, and the broadcast address. Similarly, on the second network, let's do another example. My second network would be 001. So if I want to write 001, it would be 32. We wrote that already. My first usable host, though, 001. This is my network portion. In the same octet, my first usable host is going to be this number, 32 plus 1, which is 33. This is my first usable one. On the same network, my broadcast on 001, this network would be, because the first 3 bits represent the network portion, the last 5 bits represent the host portion. All ones in the host portion is the broadcast. So on this network, it's 32 plus 16, 48 plus 8, 56, 60, 62, 63. So 63 over here becomes my broadcast, and 11110 becomes my last usable address on this 32 network, which turns out to be -1 from here because I'm taking the 1 off, which is 62, the last usable one. So that's what this is. On the third network, which would have been 010, so again, if I change this to 010, my host portion is still the same. It just starts with 64, so this becomes 65. This becomes 64 plus 16, 80, 88, 92, 94, 95, which is my broadcast, and 94 would become the last usable one. So 65, 94, 95. All right, so on and so forth. And I've done it for each one of those networks, but it's a lot of binary math that I had to do over here to figure this out. But these are your 5 steps of subnetting. Again, to recap, what are the 5 steps of subnetting? Number 1, find or figure out the number of networks required. Number 2, find the number of bits required. Number 3, write the new subnet mask. 4, write the new networks. And number 5, write the range for each network. When I say write the range, what do I mean? The first, the last, and the broadcast. That's your range. First usable address, last usable address, and the broadcast address. All right? So rather than doing it based on binary, I have my own method of doing subnetting that does not involve any binary math. So if you don't like binary math, this is exactly what you need. This is what the doctor ordered for you guys. So let's take a look at my simple subnetting steps. 5 simple steps to figure this out. Now, the first thing, find the number of networks that are required. Again, this would be based on your requirement. I cannot help you with that. You need to take a look at your network, figure out how many departments do you have, how many subnetworks would you require. So you figure that out. So let's say we'll do this example over here. I need 6 networks. Now, do you guys remember I showed you this subnet table earlier on, or subnetting table? I showed you how to create it. Start with 1, move from right to left till 7. Start with 2, double it up, again right to left. That's the number of networks that you will get. So now my requirement over here is what? 6 networks. So if I have 6 networks on the bottom line, and I tell you over here, if you need 6 networks, you move on the bottom line from which side to which side? From right to left until you hit your number. So 2, not enough. 4, not enough. 8, good enough. So I need to borrow how many bits? 3 bits. So in my simple subnetting steps, the first step, figure out the number of networks that are required. Step 2, figure out the number of bits to borrow based on this table that I have, my easy, simple subnetting table. All right. Once this is done, I'm going to use the subnetting table again. But this time around, the first time around, I went from where? This way to figure out what? That I need to get 3 bits. Now, I figured out that I need to borrow 3 bits. Once I figure that out, the next thing that I need to do is find this magic number for me known as the increment number. This will help you immensely. To figure the increment number off, the way you do that is you take that number that you figure out, that is 3 bits, and jump from left to right 3 times. Why 3 times? Because you're borrowing 3 bits. So I'm going to jump from left to right 3 times. 1, 2, and 3, and land on 32. Whatever I land on becomes my increment number. Don't worry about it. I will explain what the increment number is, but just for my sake, figure out what the increment number is. And how do I figure out what the increment number is going to be? You first figure out the number of bits that you need to borrow. In our example, I needed to get 6 networks, so I needed to borrow 3 bits. If I need to borrow 3 bits, I figured out going from right to left. Now you need to figure out, based on the bits that you need to borrow, what the increment number is, but you move from left to right 3 times. 1, 2, and 3, you land on 32. That becomes your increment number. Let's do another example just for the sake of it. If I needed 10 networks, that means I would borrow, 3 is not good enough, I need 4 bits. So 4 is the number of bits to borrow. Now, because I need 4 bits to borrow, I will move on my bottom line left to right 4 times. 1, 2, 3, and 4. So my increment number then in that case becomes 16. Good so far? Everybody understand that? So your increment number over there is 16. If I wanted to borrow or get, my requirement was 20 networks. So let's say the answer over here was 20. So if the answer is 20, let's move and find 20 on our magic table over here, right over here. 20, 5 bits would give me 20 because 4 bits would only give me 16 networks. So 5. So once I find 5, I move 5 times from left to right, and I land on 8. So 8 is my increment number. So depending on the number of bits that I need to borrow, I will use this table to find my increment number. And I also showed you how to create this table. Now, what do I use this increment number for? A lot of things. The last 2 steps are based on the increment number. Do you guys remember that subnet mask that I had to create? The new subnet mask that I had to write? The new subnet mask, it started at 255, 255, 2550, which could also be written as /24. Now let's take this example again. Let's jump back to this example. 6 bits or 6 networks, that means 3 bits. My increment number is 32. If 32 is my increment number and I borrow 3 bits, this I automatically know I borrow 3 bits, it's 27. And this guy over here, 255, 255, 255, to get the new subnet mask, you take 256, which is a static number, subtract the increment from it, and you get this new number, which is 224. So rather than adding that 128, 64, 32, you just subtract whatever your increment number is. Whatever your increment number is from 256, you will get the new mask. So for example, if my increment was 16, my new mask would have been 240. All right. In my case over here, though, my increment is 32. So 32 minus 256 gives me 224. This is the constant over here. Whatever your increment number is, you subtract it from 256, you get that new mask over here. So my first 4 steps are done. My next step is going to be to write the new networks, and on those new networks, you're going to write the first, the last, and the broadcast. How do I go about doing it? The way you do that is in the last step, I'm going to do it on my whiteboard over here. So my new networks, the way I write them, I'm not going to do any binary on it. My first network is 0, always, /27. My second network is going to be based on my increment. Do you guys remember what my increment is? 32. So this is my next network, my second new subnet. My third new subnet is just you keep on adding 32 to the previous network. So 32 plus 32 becomes 64. That's my third network. My fourth network, add 32 to the last number, go in increments of whatever your increment number is. So whatever your increment number is, those are your new network numbers. So 128, 160, 192, and on all I'm doing is adding my increment number to the last network, and that's my new network. So these are my 8 new networks. Remember, I borrowed 3 bits. I know I got 8 networks. These are my 8 new networks. So I could write those 8 new networks without doing any binary math. Now, not only that, the first, the last, and the broadcast. The first address is 1 more than this number, 1 more than your network. So my first usable address would be 200.1.1.1. One more, because you add 1 to the network, which is 1. Your broadcast is going to be 1 less than the next network. So your broadcast is going to be 200.1.1.31. Make sure you don't go to 32. So 1 less than that is your broadcast. And the last usable one is 1 less than the broadcast, 32. So your range is 1 to 30, 31 being broadcast on the 0 network. On the 32 network, again, as I said, add 1 to the network gives you the first usable host. So that would be 200.1.1.33, first usable one. Broadcast is going to be 1 less than the next network, which is 63. And the last usable one would be 62. For the 64 network, 200.1.1.65 is first, 200.1.1.95 is broadcast, 200.1.1.94 is last usable one. This guy the same way, 200.1.1.129 is the first, 200.1.1.159 is the last, 200.1.1.158 is the last. Sorry, this is the broadcast and this is the last usable one. On the 160 network now, 11161, first, 11191 is the broadcast, 190 is the last usable one. Now this one over here, 200.1.1.193, 200.1.1.223, 200.1.1.222 is the last usable one. First, last, and broadcast. Now, there's a dilemma on the last one. What happens on the last one? Again, although I'm not going to use the next one, my increment, the next increment would have been 256. That's your ceiling. use that as a ceiling, not as the next network, because I only gained 8. So it would have been 200, 225 is my first usable one. 200, 1, use this as a ceiling. So 255 becomes broadcast, and 200.1.1.254 becomes the last usable one. So that's the way you do subnetting. All right, again, to recap 5 steps. I'm doing it over and over again. I'm repeating it so that you guys understand that. This is one of the most important topics in this video series. Number 1, find the number of nets. Number 2, find the number of bits. And how do I do that? That table that I created for you, 1, 2, 3, 4, 5, 6, and 7, and underneath that table, start with 2, double up. And now to figure the bits, how do I do it? I'll use red to do the bits. I go from left to right until I hit my number. So if I needed 10 networks, I would land on more than 8. So it's 16 networks I'll gain by getting 4 bits. So 4 is my answer over here. My third step, find the increment. And what is my increment going to be? I'll use the green. This time I move from left to right. How many times? 4 times. 1, 2, 3, and 4. So I land on 16. 16 becomes my increment. So for finding the increment, it is from left to right. Finding the number of bits, it's from right to left. So now that I've found that, my next step over here, step number 4, write the subnet. And how do I write the subnet? Take 256, subtract the increment from it. So that becomes 240. So my new network would have been, or sorry, new subnet mask would have been 255, 255, 255, 240, or I borrowed 4 bits, it is going to be /28 because I start with 24. And now the last step, write the new networks within the network. You need to write the range. And how do I do it? Start with 0. So if I started with 200 as my first network, 0 is my first network /28. My second network would be 200, 1. My increment is 16. So 16 /28. The third network, 32 /28. The next one, 48 /28. So on and so forth. All right. Good so far, guys? Everybody okay with this? Hopefully you're good. But again, I'm going to reiterate these things in more examples over here. So this is the simple steps. Let's do an example over here for Class C. What I'm going to do over here is use this as my requirement. So what is my requirement over here? Actually, that was the one that I was doing. 200.1.1.1 into what? 10 subnets. How do I do it? Simple steps. How many networks required? 10. That is my requirement over here. Number of bits to borrow. Again, you go on the table, left to right. How? Why is it 4? Because I need 10 networks. 8 would not suffice. So 3 bits would not suffice. I need to get 4 bits to get 16 networks. I need 10, but 16 is good enough for 10. So 4 bits, that's the answer over here. Now that I've found that out, I need to find my increment. How do I do it? I've shown you the arrow, increment on the same table, but from left to right this time around 4 times, because I need to borrow 4 bits. 1, 2, 3, 4. I land on 16. 16 becomes my increment. Now 16 is my increment. Based on that, I'm going to write my new mask, 256 minus the increment, which is 16, which gives me 240. So you would write 255, 255, 255. In the new octet that I borrowed is 240, or /28. Why /28? Started with 24, borrowed 4 bits, so it's /28. Two different ways of writing the same thing. Now my new networks start with 0. All right? Keep on adding in increments of whatever the increment number is. 16, 32, 48, 64, 80, 96, 112, 128, 144, so on and so forth. Okay? Now on each one, I also need to write the range. How would I write the range over here? That's on the next slide over here. So my first network is 1, 16, 32, 48, 64, 80, 96. So as I said, the first host is 1 more than the network, so 200.200.11.1. The broadcast is 1 less than the next one, which is 15. And the last usable host is 1 less than the broadcast, which is 14. Now on the 16 network, the first usable one is 17, because 16 is the network address. The broadcast is going to be 1 less than the next increment, which is 32. So the broadcast has to be 31, 1 less than that. And 30 is the last usable one, which is 1 less than the broadcast. Again, on the 48 network, 49 is my first usable one. 64 is my next network, so this is wrong. This should be what over here, guys? 63 as my broadcast on this network, and this would be 62 as my last usable one. All right, on this 64 network, 65 is the first one, 80 is the upper block, so 79 is the broadcast, 78 last usable one. On the 80 network, 81 is the first one, upper block is 96, so 95 is my broadcast, 94 is my last usable one. And 97 on the 96 network. My next network over here, this doesn't seem right, it would have been 112 over here. My next network would have been 112, so this would have been 111, and this one would be 110. All right, so I'll save this as well for you guys. So that's a subnetting example for class C networks. All right, so this takes care of class C. I was working on 1 octet for the network as well as the host portion. The second example that I'm doing over here, well, actually it's still class C. So let's do another example for class C. Same concept. Let's see how it works. It's going to be a lot quicker now because you understand it. So 200.110, but I'm going to break it down into 6 networks. So if I want to break it down into 6 networks, 6 can be accomplished by just borrowing 3 bits. If I'm borrowing 3 bits, I'm going to move from left to right only 3 times, and I landed on 32. 32 becomes my increment number. If that's my increment number, my new mask will be 256 minus 32, the increment number, which is 224. 255, 255, 255, 224. Because I borrowed 3 bits, it's /27. The new networks, again, I started with 0 and started adding the increment. 32, 64, 96, 128, 160, 192, and 224. That would have been the 8 new networks that I would have gained. And I've written that down for you guys in your table as well, along with the first, last, and the broadcast. So on this one, 200.110, my first usable host over here is 1. My broadcast is 31, just like over here, because of 32 being the upper limit. 30 is the last usable one. on the 32 network. 33 is the first one, 63 is broadcast, 62 is the last usable one. How did I know it's 63? Because the next upper limit is the next network, which is 64. So 65, 194, 95, 96, 97, 126, 127. Why 127? Because 128 is your next limit, and so on. Okay, so that is how you do subnetting for Class C. Now, Class C, I had to work with the same octet, the last octet for my host, as well as my the new network bits. I was borrowing from my host bits. The first usable host bit I was borrowing. Now, what if I have a Class B network? Now, over here, I'm going to take a look at a Class B network where I subnet a Class B network. In this example, I have an extra octet that I have for hosts. So I'll take 150.500, which is a Class B network, and I want to get 50 new networks from it. So how do I go about doing that? Using the same formula. Number one, I already know it is 50 new networks. And what was my network address over here again? Let me just see. 150.5. So I write that down at the top, 150.5.0.0/16. Now, number two, find the number of bits. Again, the same formula. I have 50. The only difference is I'm going to be doing this in the third octet, not the fourth one, because this is where my host portion starts. So my host portion over here right now is this guy. So if I want to borrow X number of bits, I'm going to borrow it right over here. So 50 networks, 1, 2, 3, 4, 5, 6, and 7. Start with 2, 4, 8, 16, 32, 64, 128. So if I need 50 networks, I need to borrow 6 bits because 5 would only give me 32. And that 6 bits would give me 64 networks. But at the same time, if the answer over here is 6, what's my increment number? 6 times over, right? 1, 2, 3, 4, 5, 6. So this is 4. So my increment over here is going to be 4. Again, following the same 5 steps. Step number 4 is the new mask. Now remember, this is a separate or an extra octet. So 255 was the default. In the third octet, I'm going to say 252. Why 252? 256 minus 4, which is 252.0, which basically means right now, the way this has been split is I have turned the first 6 bits, because I borrowed 6 bits, into what? The network, and these remain to be the host. So 2 bits over here and the entire octet is host. So what are these two? These two are the first 2 host bits, and the first 6 over here are the network bits. So the new networks that I'm going to gain are going to be like this. Let's write that down. 150.5.0.0 slash, it started with 16, I borrowed 6 bits, becomes 22, or this new mask. The next one, 150.5.4. Why 4? My increment is 4. My next network, 5.8.0, 150.5.12.0, 16.0, 20.0. Okay, and so on. So the increment is 4 basically. You get about 64 new networks. Now how do I write my first, last, and broadcast? Now my first one, now I'm not going to add 1 over here because my host portion is right over here. So if you take a look at it, my 1 would be added at the end over here. So it'd be 0, 0 and 0, 0, 0, 0, 1. So my first usable host on this particular network would be 150.5.0.1. 0 over here, dot 1 at the end. Because I'm going to add the first host over here, not over here. Before, the same octet was network and host, so that's why I would take in the network address into consideration. But now the network portion is on the other side. But where it does matter is on the broadcast. Now, when I do the broadcast, these bits along with the network bits are going to be taken into consideration. My broadcast would be this number. So this would be 255 in the last octet. So that is a given. This number over here is going to be 1 less than the upper limit. So it would be 3. 150.5.3.255, and the last usable one would be 150.5.3.254. 1 less than this would be your last usable one. So 0 over here, which would be 254. So that would be your last usable one. So 150.5.0.1 through 150.5.3, which is the upper limit block on the next one, 255 as the broadcast, 254 as the last usable one. On the next one, which is 150.5.4, my first address, 150.5.4.1, my upper limit is 8. So in the third octet, 150.5.7.255 is my broadcast, and 7.254 is going to be my last usable one. Another way of looking at it, the last octet of my first, last, and broadcast for a class B is always going to be 1, 254, and 255. The changing will happen in the third octet, the one that I borrowed from. So again, taking one step further, on the 8 network, my first address, 150.5.8.1, 150.5. My upper limit is 12, so 11.255 is the broadcast, 11.254 is the last usable one. On the 12 network, 150.5.12.1, my first one, 150.5.15.255 as the broadcast, last usable one, 15.254. On the 16 network again, 16.1 as the first usable one, the broadcast and the last usable one, the broadcast is 19.255 and the last usable one is 254. So on and so forth. And I'll put that in your table as well. So I just wanted to write it before I would show it to you guys. So this is my example for that 150 network, 50 networks required, 6 bits to borrow. That's what I did. My increment is 4. So my new mask is 255.255.252.0 because I'm working with a third octet in a class B /22. What are the new networks? 150. This should have been 5. I'll just change it over here. It makes it easier. 150.1.0.0/22. Next one is 4, 8, 12, 16, 20, 24, 28, 32, so on and so forth. You get 64 such networks. And in your table, okay, this one does have that 5 again, so I'll change that to 1. Oh man, this is going to be a tough one. So let's go back and change this. Doesn't matter, my main objective over here is not this address. My main objective was the subnetting portion, which I think I have gotten across to you guys. Hopefully. Let me just make this correction. All right, so that fixes it. So now if I go back over here, my first network is 150.5.0.0. 252 is my mask. The first usable one, 501. The last, actually the broadcast is 5. Why 3? Because 3 is the number before 4. 4 is your upper limit. 3.255 in the third octet is the limit, 255. 254 is the last usable one. For the 4 network, 4.1, this would be 7.255. Why 7? 8 is the upper limit. 5.7.255, 7.254 as the last usable one. On the 8 network, 8.1, the upper limit is going to be 11. Why 11? Because this is 12. 11.254 is the last usable host. For the 12 network, 12.1, this is going to be 15.255. Why 15? The upper limit is 16. The next network is 16. So 15 is the last usable one. Broadcast 15.255 is the broadcast. 15.254 is the last usable one. On the 16 network, 16.1 is the first. 16.255 is the broadcast. Not 16, sorry. 19.255 is the broadcast. 19.254 is the last usable one. On the 20 network, 20.1, 23.255 is the broadcast. 23.254 is the last usable one. On the 24 network, 28 is the next hop or the next network based on the increment. 24.1 is the first one. This would be 27. Why 27? Because 28 would have been the next one. 27.254 is your last usable one. So that's a class B subnetting that you did. Okay, so that's class B. Again, I borrowed 6 bits in this case. The last subnetting that I would do over here is for a class A network. And that is the last one that we need to do over here. In a class A network, I'm going to start with the first octet as the network and the last 3 octets as my host portion. Now, the way you do it is exactly the same. The only difference is you have an extra octet for hosts over here. So for example, in this particular requirement, I need to break down the 60 network over here into 30 new subnets. Now, the 30 new subnets, using the same formula, same steps that I talked about earlier on, we'll use the 5 simple steps. 30 networks. How many bits to borrow? 30 will get me here based on 32, so 5 bits to borrow. Now that I know I need to borrow 5 bits, find the increment by moving from left to right 5 times. 1, 2, 3, 4, 5. So that's 8. Nothing has changed so far. Now in the mask though, my default mask over here was 255.0.0.0. Now when I write the new mask, which is based on 256 minus the increment, which is 8, you get 248. So the new one would have been 255.248.0.0 because now you have 2 extra octets worth of host addresses. I've just borrowed in the second octet. The third octet and the fourth octet is still host. So you still have a lot of hosts on the class A subnet. What are the new networks again? Because I just borrowed from the second octet, my number that will change is over here. So it's going to be 60.0.0.0 slash 13. Why 13? I started with 8 and I borrowed what? 5 bits. So that 8 plus 5 is 13. My next network over here is 60.8. Why 8? My increment is 8. So 60.8 would be my second network, third network, fourth network, fifth, sixth, all in increments of the increment number. Now the thing about this I want you guys to see as well is how does it pan out in terms of binary. So I started with 60 and I borrowed 5 bits. So those now become my first network. My host bits over here are 3 in the second octet. The entire third octet and entire fourth octet are still host bits. All right, so when I'm changing, I'm going to be changing the second octet. The third octet and the fourth octet are going to be all host addresses. So my first usable one, if I want to do it in binary so that you have an understanding of it, my first usable address would be changing this to 1. And if I change this to 1, that address becomes, so the first address becomes 60 dot, this is 0 dot 0 dot 1, because I changed 1 on the end. And the broadcast for this one, I'll put the broadcast would have been what? Turning all the host bits to 1. That would be my broadcast. Now to get that broadcast address in your decimal, 0000111, 111 is 4 plus 2 plus 1, which is 7. If you remember, the next network would have been 60.8 because my increment is 8, so 1 less than the increment. But now I have another octet for my broadcast, which is 255, and another octet for 255. So 2 octets for 255 for my broadcast. And the last usable one, I would turn this to 0. So that's the last usable one. So 60.7 again, 111, all ones over here, 255, but on the last octet, 254. So that's your last usable one. On the 8 network, everything would remain the same. The only thing is I would change this to 8. So my first usable address would be 801. So it would be 801. My broadcast would be 60. Now, 8 plus 4, 12, plus 2, 14, plus 1, 15. Because the increment, the next increment would have been 16, so 15. Dot 255. 255 is the broadcast, and the last usable one would be 60.15.255.254 in the last octet for the last usable one. Now that's what I've tried to do over here, guys, in your table. I just want you guys to see the binary equivalent of it as well. So the first network is 60.000.255.248. Why 248? You subtract the increment from 256, you get 248.00. 60.001 is the first one. Again, upper limit is the next increment, which is 8. So 7.255.254 is my last host. 7.255.255 is the broadcast. 68, the first usable address, 6801. 6015, why 15? The stopper over here is 16. 255, 254. 255, 255 is your broadcast. 24, 24.0.1. 31, which is the one number less than the increment. So the next increment, 31.255.254. 255.255 is the broadcast, so on and so forth. And that is subnetting for you. You did Class A, Class B, and Class C. To recap, 5 steps. Write, or not write, sorry. Figure out the number of nets or networks required. Number 2, find the bits required, and that is based on that table. Write new mask. Number 4, sorry, this is 4. Find the increment. Write the new mask. This is 256 minus increment 5. Write the network or new networks. And how did I do it? Based on increments. So let's say my increment was 16. Let's do a class C. 0 would be my first network. Increment 16 means I have borrowed 4 bits. My next network would have been the increment of 16, 32, and we'll write 4 of them, and 48. Why 48? Because the increment is 16. Write the new networks based on the increments. Write the first, last, and broadcast on each one. How did I do that? First one is 1 greater than your network address. Broadcast is 1 less than the next increment. Next, the last usable one, 1 less than the broadcast. So again, 200, 117, 1 more than the network. Broadcast is 1 less than the next increment, which is going to be 31. Last usable one, 1 less than the broadcast. 200, 133, 1 more than the network. 1 less than the next increment, which is 47. And 1 less than the broadcast is your first, last broadcast, and so on and so forth. All right, that is subnetting. Now let's take a look at the review questions. I'll go through them with you guys. Not everything, but some of them. But real quick, you have a class C address of 192.1.5.0. You would like to break it into 7 subnets. So if I need 7 subnets, how do I go about doing it? 7 subnets. My first question is answered. Second one, subnet 7, 1, 2, 3, 4, 5, 6, 7, 2, 4, 8, 16, 32, 64, 128. 7 would lead me to 3 bits. If 3 is my bits, I jump from left to right 3 times, 32. My subnet mask is 255, 255. It's a class C. 224. How's it 224? 256 minus 32, 224, or you can say slash 27 because I borrowed 3 bits. My new networks are in increments of what? 32. So my first network on that whatever class C network I have is 0. Next one is 32. The next one is 64, 96. My first usable one, 1. My last usable one, actually the broadcast is 31. Last usable one is 30. On this network, 33 the first one, 1 more than the network. 63 the broadcast, 1 less than the next increment. 62. On the 64 network, 65 is the first usable one. 95 is the broadcast. 94 is the last usable one. So on and so forth. Hopefully you understand that. That is an exercise that I want you guys to do. You have a class B network of 150.5. You want to break it down into 15 subnets. If I need 15 subnets, again, same table. 2, 4, 8, 16, 32, 64, 128, 7. No, sorry, this one, 15. So I'm okay with 5 bits. If I need 5 bits, 1, 2, 3, 4, 5, 8 is my increment. So if 8 is my increment and my new mask is 255, it's a class B, 255, 248.0, or slash 16 plus 5, which is 21. What are the new networks? My mask is, or sorry, my increment is 8. So 150.5.0 as my first, slash 21. Why 21? 16 plus, what do you call it? 5. My next one, my increment, 8. 150.5.16. 150.5.24, so on. First usable one over here, 150.5.0.1. My broadcast, 150.5.7, because 8 is the upper limit, 255, and 254 would be the last usable one, 7.254. So over here, 150.5.8.1, the upper limit is 16, so it would be 150.5.15.255 is the broadcast, 15.254 is the last usable one on the 16 network, 5.16.1, 24 is your next increment, so 23.255, 23.254. That takes care of this one as well. Class A, 15.000, you need to break it down into 50 subnets. Again, 50 subnets. Should not have erased that, but that's okay. 2, 4, 8, 16, 32, 64. I got my number of bits is 6. By why I need 50 networks. So 6 means my increment is 1, 2, 3, 4, 5, 6. So 4 is my increment. So my first network, or my first of all, 4 is my increment. So my mask is 255, 252.0.0. It's a class A network. Okay. Or slash, I borrowed how many bits? 6 bits. So my mask is slash 16. My first network, 50.0.0.0 slash 14, 50.4.0.0 slash 14. Next one is 50.8.0.0 slash 14, 50.12.0.0 slash 14 in that increment. So over here, my first usable address, 50.0.0.1. My broadcast 50, upper limit is 8, so 7, 255, 1 extra octet, 255. Last usable one, 7, 255, 254 on the last octet. On the 8 network, I'll write it over here. On the 8 network, my first usable one is 50.8.0.1. My upper limit is for 8 is going to be 12. So for 12, 50.11.255.255 is my broadcast. 11.255.254 is my last usable one. So that's C, and so on and so forth. Now class question number 4. If you have subnetted a network 172.16 and with a mask of 20, that means you borrowed 4 bits. So you have borrowed 4 bits. If you borrowed 4 bits, your increment is 16. So if you have a question like that, reverse engineer it. You have 20 bits that you've taken is your mask. Your default mask would have been 16. It's a class B network. Okay? So that means you borrowed 4 bits. If you borrow 4 bits, you move on your table from left to right 4 times, you land on 16. Which of the following are broadcast addresses? So you figure out on that network, what are your increments? 16.0.0 actually starts with what? 172.16.0.0 slash 20. My next one would have been 172.16.16.0, 172.16.32.0. It's a table of 16 basically. Now you need to figure out the broadcast. Is this a broadcast address? So if it's the 32 network, 32 on this network, what is my first usable host? 172.16.32.1. The next network after that, or the next subnet after 32 would have been, it's an increment of 16, so it would have been 48. So on this network, my broadcast would have been 16.47.255 on the 32 network. It's on the 32 network. And my last usable one would have been 254. So on the 32 network, 32.255 is not a broadcast. On the 32 network, 47 is a broadcast. So this is not a broadcast. Which of the following are broadcast addresses? This is not a broadcast. How about this one? We just got that 47.255 in that example. This was a broadcast, so this is a broadcast. 16.79.255. Again, is that a broadcast or not? As I said, it's a table of 16. So my first network is 16, 0, 16, 32, 48, 64, 79. Oh, 79 over here. 79 is that, sorry, not 79, 80. So my upper limit on this network is 79. So if I had to write this network down in detail, it would have been 16. 64.0 is the network. 64.1 is the first usable host. My broadcast would be 79. Why 79? The upper limit is 80. 255. Ooh, this guy. Broadcast. This one, again, going in increments of 16. So keep on going. I've gotten up to 80. So the next one after 80 would have been 96, 112, 128, 144, 160. And that's where I land. 159 is between these two guys. So 140 is my network. 144.0. So 144.1 is my first. This is my upper limit, so 159.255 is my broadcast. Ooh, there you go. So these three are broadcast. So the way I figure out is I see where they land based on my increment and then see if it's a broadcast on that particular network. Similar type of question, if your mask is 255, 255, 255, 224, which of the following are valid IP addresses? Now, if it's 224, that means my increment is 256 minus 224 is 32. 32 means I borrowed 3 bits. How do I know that? If my increment is 3, that means I've gone 3 times. 128, 64, and 32. So this is my increment. Okay? So I figured out my increment. Now, based on that, figure out if these addresses are valid addresses. Valid addresses means they're within the first and last. They're not broadcast addresses or network addresses. So 32 is my host address. This is a class C address. 192.165.4 is a class C address. 32 is my increment. So in this, my range is 33 through 62, where 63 is my broadcast. Why is 63 my broadcast? Because 64 is my next network. So for that, I know it's a valid address because it's within my range. Now let's take a look at the other one. 195, again a class C address. Same mask, so the first 3 octets don't matter. 195.5.2 increments of 32. So what are my networks? 0, 32, 64. Now where does this number land on? 63. It lands between 32 and 64. So it's basically on the 32 network. On this, the valid range is 33 through 62 because 63 is broadcast. Oh, this is a broadcast address. Invalid. So B is invalid. Now let's take a look at the third one. 172, 16, 5. So this still is part of what? The network address because of the first 3 octets. On the fourth octet, you have 224. You have a fourth octet as 224. That means, again, increments of 32. 0, 32, 64. This number 32 is the network address. So network address is an invalid address. So these two are invalid so far. How about this guy? Again, taking a look at the mask, 11.5.1 is my network, and then I have what? Increments of 32 because of my mask. So 0, 32, 64, 96. This number is between 64 and 96, so that means it's on the 64 network. On the 64 network, my first usable host, 65. My broadcast is one less than the next increment, which is 95. Last usable one is 94. So this is a valid number. So again, the wrong ones, which of the following are valid addresses? This is a valid address. This was a valid address. On this one, we had figured out that which of the following are broadcast addresses. This was a broadcast address. This was a broadcast address, and this was a broadcast address. Again, you need to take a look at this video maybe a couple of times, but if you do that, I promise you, you will know subnetting. This is the easiest way of doing subnetting. I believe that if you do this a couple of times, you will master it. Very, very important topic in this series. Hope you enjoyed it. See you again in the next video.